All right, so to start off today, we are going to just look at one object, which is a cylinder. All right, but we're going to look at two different things about a cylinder. Now, the first thing we've already covered, and that's volume. And just a little recap here is that volume is the amount of space that an object takes up. All right, so that's the amount of space an object takes up. Now, again, we're looking at a cylinder here. We're going to look at another thing called surface area. And the way I look at a surface area is it's the amount of squares needed to cover an object. All right, so the amount of squares. Now, again, that's going to be a key word here, squares. All right, but we're just trying to cover the object. So we got volume is the amount of space that an object takes up, but yet surface area is the amount of squares just needed to cover the object. So nothing to do with the inside of the object. All right, so we got a couple of formulas here. We got two of them here, one for volume. SA here. It's not Spanish for SA, my friend. It's surface area. All right, now, what you're going to find out today is that our formulas are going to be bigger and more complicated. Some of them are. But again, we're just going to follow the same steps. That's the beautiful thing about what's going on here. All right, now, the volume, there's our formula. It's pi, familiar thing, r squared times h. I don't think that formula is any harder than the ones we did the other day. But then we get to surface area. A little bit more difficult because we get two different pieces to our formula. And so 2 pi r squared is part of it. And how they come up with that is like pi r squared, I'm not sure if you've done this before, is the area of a circle. And when you have a can or a cylinder, there's a circle on the top and there's a circle on the bottom. So pi r squared, that's why there are two there. One's for the top, one's for the bottom. And then the 2 pi rh, basically, it's like a can of soup. If you put a label around it, that would be the area that you're covering around the can. All right, so like I said, you need because we're looking at, again, the surface area, which is how many squares it takes to cover an object. Well, you got to cover the top of a can, the bottom of a can, and then, if you're wrapping around a can, a label, basically it's going to be a rectangle that you're going to wrap around it. All right, so one of the parts of the formula represents the rectangle, and the other part of the formula represents the two circles to cover the top and bottom. Now, one thing is, even though I'm talking about the amount of squares it takes to cover an object, it's not like they're perfect squares. We can take a square and cut it into pieces because, you can't cover a circle with like single squares. You have to, modify them a little bit, and then you might use parts of them. All right, so on further moving on here, speaking of, we got our chicken noodle soup here. All right, so I'm going to find the volume and surface area for the following cylinder. So I'm going to go with the volume first because we're used to that. All right, so again, volume is equal to pi r squared times h. All right, so again, what I do is, and I'm going to post a formula sheet today that you're going to be able to use for all the shapes because we're kind of building up our formulas, right? We're getting a lot of them, and on the next day, which is our CAT, you know what I mean? I don't want you looking for the formulas. They're going to be all on one sheet for you. Now, again, I'm following the same format here as I did for all the other shapes. I write down my formula, and variables, well, it's already telling me the variables. There's my R, there's my H. That makes it easy, right? So on to my second step, which is substituting in. Now, again, I don't like symbols or fractions, so there's pi, 3.14. My radius, again, it's already labeled for me as 4, so I'm going to have a 4 squared here. And then my H is 7. All right, so again, when we're doing these formulas, the key thing here is you got to follow Bedmas. And so next up here, we have our exponent. All right, so I'm going to take my 3.14. I'm not touching that. Now, my R4 squared, again, that means 4 times 4. Not 2 times 4, 4 times 4. All right, and that's 16, and then times 7. All right, now my last step, as usual, is, well, I'm going to finish off my calculations here. So I'm going to take my 3.14. Then I times it by 16. Then I times it by 7. Again, I always write my answers down to 2 decimal places, right? So I got 351.68. Now the last part of this, I get my units in there. And again, the can is a 3-dimensional object, so it's centimeters cubed. All right, so that's the volume of our can. Now it also says, the new thing here, the surface area. All right, now the formula for that, again, was volume is equal to 2 pi r squared. But then we have a second part here, plus 2 pi r h. All right. What do we need here? Just making sure I got everything. Pi is a number. I got it. R, we got that. Pi again, I got it. R and H. Well, we have all those things, so we're good. All right, so now I'm going to substitute in. Right, I got my formula, got my variables. Now to substitute in. So 2 times pi, which is, again, my 3.14. R was 4. All right, so I got a 4, and then that's R squared. So I'm going to have to do a 4 squared here. All right, plus 2 pi RH. So then I got 2. Pi again was 3.14. R again was 4. This time we don't have to square it because it's not on there. But then we got these H at the end, which is 7. All right, so now it's the calculating part. And as I said, bedmiss. So here we go. Brackets. Well, yeah, we got brackets, but nothing's going on inside them. But I do have an exponent, so I got to do that. So let's see here. I go 2 times 3.14. All right, 4 squared. We already did that one, right? 4 times 4 is 16. All right, plus, now we got the second part. I got to write all that out. All right, 2 times 3.14. All right, times 4 times 7. Okay. We did the exponent. So next in bedmiss is either division or multiplication. We definitely got multiplying. We got it twice. We got 2 parts to multiply. We got these 3 numbers I got to multiply, and then they're separated here, and then I got 4 numbers to multiply. All right, so here we go. So that's why this formula is a little bit tougher. It's got more parts to it. All right, so I'm going to do the first part here. We got 2 times 3.14 times 16, and I get 100.48. Again, I'm going to 2 decimal places. All right, plus. Now I got to do the second part where I've got to multiply the 4 numbers. So I got 2 times 3.14 times 4 times 7. Now I'm getting 175.84. All right. Now I'm still not done yet because I'm still going through bedmiss, right? Division and multiplication is done. Now it's addition and subtraction. Well, I do have some addition. And so this is my final step here. I'm going to add these 2 numbers together. So take my 100.48 and I add 175.84. And again, throwing down my answer here to 2 decimal places. All right, now the units. Now this is where people struggle a little bit. Now this is a 3-dimensional object, but we're talking about how many squares we can wrap this can of soup with. So because it's the amount of squares we're wrapping it up with, it's centimeters squared instead, because we're just talking about, whoa, see what I did here? I messed up something here, folks. Volume. What am I talking about? This is surface area. Surface area. Already did volume. Boom. Cut this out. I'm talking about the surface area. And again, it's like when you're wrapping a present. Now, I'm not one to give advice on wrapping presents because everybody in my family laughs when they when they look at their present because I'm terrible at wrapping. But when I put the wrapping paper down, it's flat on the ground, right? So it's not three-dimensional, right? And that's why we have how many squares it takes. All right, so it's 276.32 centimeters squared to wrap this can of soup. All right, let's try a couple more here. What do we got? Find the volume and the surface area. I'm going to skip this one. I'm going to another one here. Here we go. Yeah, this one. Find the volume and surface area for the following cylinder. So we got a new cylinder. We're going to do again volume and surface area. So again, volume is equal to pi r squared times h. So I got my formula down. Now, can anybody see? I always throw a little trick at you, right? We always do an example that's straightforward, and then the next one's kind of a trick. Anybody see what the catch is here? The trick or the catch? It's always a catch, right? I'm checking out the chat here. No? All right, well, here's the catch here. Is that when I'm finding my variables here, I need the radius, I need the height. Well, the height is straight up from top to bottom. That's 12 right there. But the radius is from the center of a circle to the outside. This line's telling you it's all the way across, right? If I get rid of that red line again, see that line's telling you that 16 is all the way across. So that's actually what's called your diameter. We only want halfway across, so we take half of 16. So that half of 16 is 8. So there's a little catch there. All right, but the rest is the same. So I've got my variables down, and now I'm going to substitute in. So my pi there, I'm not putting in a symbol. I'm going to put in a number, 3.14. My radius, which again I found out is 8. And that's squared. All right, and then my height is 12. All right, now, volume. That's what I'm figuring out. All right, following Bedmas. All right, so I got to do my exponent again first. So 8 squared, that's 8 times 8. 8 times 8 is 64. All right, then I got my 12. All right, so now, lucky for me, final step here is multiplying those three numbers. Then put some units on it. So we get 3.14 times 64 and then times 12. And I get 2411.52. Again, 2 decimal places. My units here are meters, and this is a three-dimensional object that's taken up space. So there we go, 2,411.52 meters cubed, as they say. All right, now we're also, like I said, find the surface area. And properly, I'll put SA here. Surface area, again, is 2 times pi times r squared plus 2 pi times RH. There it is. All right, so I'm going to substitute in, right? And I've already got my diagram labeled. Again, that's why I do it. Keeps things sorted out for me. All right, so my surface area, all I have to do is look. So I get 2 pi again, 3.14. All right, my R, we've got a lot of numbers on this diagram, but my R is 8. Okay, so I got an 8 squared. We already figured that one out, 8 times 8. All right, plus, again, the second part of this formula is 2 pieces here. So 2 times 3.14 times my R, which again is 8. And then my height was, let's see here, have a look, 12. All right. Whew. Just following Bedmas now. All right, to do my calculations. So I got to do that 8 squared. So 2 times my 3.14. 8 squared, we did that, right? That was 64. 8 times 8, right? So 64 plus Second part, well, nothing changes there. We didn't have any exponents. All right, so now we're continuing on with Bedmas. Let's go a little bigger. There we go. All right, so surface area. All right, the first part there. So I've got 2 times 3.14 and then times 64. Do that all at once and I get, whoa, 401.92 plus we got our second part. So that's where I've got my 2 times 3.14 times 8 times 12. So I'm multiplying 4 numbers this time out. All right, so I got my 2 times 3.14, all right, times 8 and times 12. So this time I'm getting 602.88. There we go. Now, we're not done yet, because the last part of Bedmas is addition and subtraction, and we do have some addition here. We're going to add those 2 numbers, and it looks like it's going to be 1,000 and something. I'm not sure yet. Whoa, SA. All right, so I take my 401.92. I add my 602.88. And yeah, I get 1,000 and something here. I get 1,004.8. Again, we got to throw some units on it. It's in meters, but again, this is the tricky part of surface area, is that we're talking about the number of squares that we are going to cover this object with. So I put a little 2 there for squares. And there we go. So again, all the same steps that we've been doing, just a little tougher formulas. Well, I don't think the volume formula is tougher than the couple of we've been doing. But again, the surface area, it's 2 parts. We still got to follow Bedmas. But again, write down our formula, put our variables in on the diagram, label things, and then substitute in. And then, of course, when we're doing our calculations, we got to follow Bedmas. And at the end, put our units in. Volume, you're talking about a 3-dimensional object, so it's cubes. And with surface area, you're talking about how many squares you're going to cover that 3-dimensional object. And so the units are always squared, whatever it is, meter squared, centimeter squared, or whatever it happens to be.